Lesson 112 is part 1 of our study of probability. And our definition of probability is the number of favorable outcomes over the total number of possible outcomes. Please pause the video now to make sure you get that in your notes. So a classic example of probability is to say, well, my chance of winning the lottery is 1 in 1 million. So the only way you can win the lottery is if you get the right combination of numbers. And you're saying there's only one way to do that, and that's right. And you're saying that there's a total of 1 million different possible numbers. So that would be an example of probability, 1 out of 1 million. Let's look at a couple examples. A deck contains 52 cards. 13 are spades, 13 are hearts, 13 are clubs, and 13 are diamonds. Jimmy tears up the ace of spades. Then he shuffles the remainder of the deck and draws one card. What is the probability the card is a spade? I don't know why Jimmy tore up the ace of spades. He must have been frustrated. But we can still figure out this question. What is the probability the card is a spade? So, since Jimmy ripped up a card, there are now only 51 total cards. So that must be the total number of outcomes possible. What is the probability the card is a spade? Well, he ripped up one spade. So we started with 13. You take one away, we must have 12. So we've got 12 out of 51. That would be the probability the card is a spade. But in this problem, we know we always have to reduce. We have to reduce fractions whenever we have them. So 12 out of 51, we're going to divide that by 3 over 3. We know both of these numbers are divisible by 3 because 1 plus 2 is 3, and that's divisible by 3. 5 plus 1 is 6, and that's divisible by 3. 12 divided by 3 is 4, and 51 divided by 3 is 17. So the probability the card is a spade must be 4/17. Now probability, you can report your answer as a fraction, you could report your answer as a decimal, or you could report your answer as a percent. In this problem, I'd recommend reporting your answer as a fraction because you don't have to do any other steps. If you wanted to turn it into a percent, well, you'd have to divide 4 divided by 17, then move the decimal twice to the right after you've got your answer to turn your decimal to a percent. But there's no need to. Let's report this one as a fraction. Here we have another problem. One 6-sided die is red, and the other die is green. Both are rolled. What is the probability of getting a sum of 7? So if we look at a 6-sided die that's red, the probability of getting a sum that's 7, well, if we look at both of our die, we could have, or both of our dice, we could have one that's a 1 and one that's a 6. That's equal to 7. We could have one give us a 2 and the other give us a 5. That's equal to 7. Could you think of any more possibilities that are equal to 7? Well, we could have 3 and a 4. 3 plus 4 is equal to 7. Well, we could also switch the way we get the dice rolled around. 4 plus 3, that's equal to 7. 5 plus 2, that's equal to 7. And 6 plus 1, that's equal to 7. So we can see there are 6 total possible ways we could get a sum of 7. So we're going to get 6 out of some number. Now in order to figure out the total number of possibilities, since we have two 6-sided dice, we need to multiply 6 times 6 to figure out the total number of possible outcomes. 6 times 6, that's 36. So the chance of getting a sum of 7 is 6/36, which must be the same as 1/6. This is part A. Now for part B asks us what's the sum of getting a 4, or the probability to get a sum of 4. Well, we could get 1 plus 3, we could get 2 plus 2, or we could get 3 plus 1. So if we look at those, we have 3 different ways. So we could have 3 out of 36, because there's still 36 total possibilities when we roll two 6-sided dice. We reduce by dividing both by 3, and we're going to get 1/12. And we've got our final answer. Again, reporting these as a fraction is a great way to work with probability and express your answer. Lesson practice will be on page 348. Make sure you've got your notes complete, and I'll see you during our next class.